Teaching is complex, and it is important for teachers to continue to develop their knowledge and skills during their careers. Professional development is considered to be particularly important in math, especially for elementary teachers who often don't take many math classes in college. Can professional development that focuses on math content improve elementary teachers' knowledge and instruction, and ultimately their students' achievement? A new report by the American Institutes for Research and commissioned by the Institute of Education Sciences at the U.S. Department of Education addresses this question. The study tested a three-part professional development, or PD, program. The first part was Intel Math, an 80-hour summer workshop to deepen teachers' knowledge of grades K to 8 math content. The second and third parts totaled 13 hours during the school year and were designed to support teachers as they built what they learned from the summer workshop into their instruction. These components of the PD included 5 collaborative meetings where teachers focused on analyzing student work to identify errors and ways to address them, and 3 one-on-one coaching sessions where teachers received feedback on the quality and clarity of their math instruction. Mike Garrett, AIR Vice President and Institute Fellow, is the study's principal investigator.
The professional development was designed to help teachers understand the underpinnings of the math they teach, so that then teachers would be able to explain them clearly to students and respond to students' questions.
165 fourth-grade teachers in 6 districts participated in the study. Teachers in each school were assigned by lottery to one of 2 groups. The first group participated in the 3-part PD. The second group participated only in their usual PD activities. This sets up a clear test of the effectiveness of the study PD.
We found that the PD had a positive impact on teachers' knowledge, a boost of 21 percentile points on a math test we gave the teachers.
Put another way, after receiving the PD, an average teacher became a top 3rd teacher in terms of their knowledge of topics like whole numbers, fractions, and rational numbers.
The PD also had an impact on one aspect of instruction. Teachers who received the PD more often gave conceptual explanations of the underlying math, such as explaining the why behind math procedures or comparing different approaches to the same problem. In other words, they taught richer math lessons. An average teacher who received the study PD provided this kind of richer instruction during 63% of a typical lesson, compared with only 46% for an average teacher who didn't receive the PD. While these improvements to knowledge and the richness of teachers' math instruction are encouraging, they didn't ultimately lead to a positive impact on achievement.
Why not? The study can't say for sure, but if PD is to improve student achievement, it should focus on aspects of knowledge and practice that are important for student learning. Correlational data from the study instead showed that students of teachers with more knowledge or richer math instruction generally did no better on math tests at the end of the school year. The study looked at 2 other teaching practices to see if the same pattern held. One of these practices looked at whether teachers used unclear, imprecise, or incorrect math language or notation in class.
We found that students in classes where teachers made errors or used imprecise math language did tend to do worse on their tests. This was the only practice we found to be correlated with achievement. Our results suggest that professional development might try to do more to fix errors and imprecision in teachers' math instruction. We might also need to find other practices and aspects of knowledge that are more strongly correlated with student achievement. These are some of the issues that future studies could look at as we continue the important work of equipping math teachers with what they need to promote student learning.